Alright, today we're going to be doing marginal analysis in business and economics. So let's go through a handful of equations first of all. So we got our total cost equation, which is simply going to be represented by C of x. And then the first derivative of the total cost equation will tell us the marginal cost equation. So that's what we are saying right here, is the first derivative of the cost function is the marginal cost. And then let's talk about revenue. So we have our total revenue equation, which will be denoted by R of x. And then the marginal revenue equation is just the first derivative of our total revenue equation. And then our profit equation will be revenue minus cost. And our marginal profit will be marginal revenue minus marginal cost. Note that we are going to denote our total profit equation as sometimes as we say P of x, or in economics we typically say pi. We write it as pi of x. So either way, we're just talking about profits. So let's talk about some examples. So let's assume we got like a bike shop, and we have a cost function represented by 10,000 plus 150x minus 0.2 x squared. So this is the function that's representing the total cost for this bike shop, given that we are producing X number of bikes. So if we wanted to figure out the exact cost, we're going to use the terminology exact cost of the 121st bike. Well, what we will do is that we're going to plug in the exact cost will be the cost of the 121st bike minus the cost of the 120th bike. So the cost of the 121st bike will simply be plugging in 121 for x into the cost function. So we're going to have 10,000 plus 150 times 121 minus 0.2 121 squared, and we plug that into a calculator. This equals to 25,221.80. So that's how much money it costs to make 121 bikes. And then we figure out how much it costs to make 120 bikes. We just plug in 120 in for x into the total cost function. So all we did was plug in 120 in for x for the total cost function, and that will tell us how much it cost us in total to produce 120 bikes. So if we know how much in total it produces to make 121 bikes, and we know the total cost of producing 120 bikes, the exact cost of producing the 121st bike will be the cost of the producing 121 bikes minus the total cost of producing 120 bikes, 101.80. So that's how we can calculate the exact cost of producing the 121st bike. Well, that was annoying. I don't know about you, but that seemed like a lot of work. So another way that we can kind of guesstimate it is that C prime of 120 will give a nice approximation of the exact cost of the 121st bike. So all we have to do is figure out what is the marginal cost equation, plug in 120 in for that x value, and that'll give us an approximation of producing the 121st bike. So first we have to calculate what C prime of x equals to. Well, remember, this is C prime of x. So that's C of x, I mean. So C prime of x will just simply be 150 minus 0.4x. So 150 minus 0.4 x. And now we can plug in C prime of 120 equal 150 minus 0.4 times 120. Well, this equals to $102 even cents. So that is a quicker way of guesstimating what is the exact cost of producing the 121st bike, is that we can simply figure out what the marginal cost is and be able to solve for what is the marginal cost at a specific value. And so that's a bit quicker. We can use the marginal cost as a substitute for finding the exact cost. Alright, let's go over some more equations. We can talk about the average cost function, which we are going to denote as C bar of x. Well, that will just equal to the total cost function divided by x. And then we can talk about the marginal average cost function, which will just be the first derivative of our average cost function. We can have a revenue per unit equation, which will equal to what we call R bar of x, will just equal to R of x divided by x. And then we can have the marginal average revenue equation, which would just be the first derivative of R bar. And then we can have our profit per unit equation. Well, that will just equal to what we call P bar of x, will just equal to P of x divided by x. And then we can talk about our marginal average profit function, which will just be the first derivative of P bar. So let's do an example of these situations. So example, let's say that we have a cost function that equals to 100 plus 2x. Let's say we have a revenue function of 7x minus 0.04x squared. Well, we can figure out what the average cost function will equal to. Well, that's C bar of x, which will equal to C of x all divided by x. Alright, well, we can then figure out what the marginal average cost function is. Okay, marginal average cost function. Well, we're just going to take the first derivative of the average cost function, but let's rewrite this in a way that we can apply the first derivative rule to. So we are going to have 100 times x to the minus 1 plus 2. So now if we want to take the first derivative of that, we would have negative 100 x to negative 2. We can come up with the average revenue new equation, R bar of x. So that is just 7x minus 0.04x squared all divided by x. We can try to calculate the marginal average revenue equation. Well, once again, we want to take the first derivative of the average revenue equation. So let's rewrite this thing in a way that makes a little more sense to us. So we're going to get 7 minus 0.04 x. And now we can take the derivative of that. And that's might be a little bit easier. So the marginal average revenue equation will just equal to 0.04 minus. Now we can talk about the profit per unit. Or let's talk about the profit function, which would just be P of x, which equals the revenue of x minus the cost of x. So in our case, that's going to be 7x minus 0.04x squared minus 100 plus 2x. So let's simplify that a little bit. We have minus 100. If we combine our x terms, we're going to have plus 5x. And we only have one x squared term, so minus 0.04 x squared. You can calculate marginal profit by taking the first derivative of our profit function, and we're just going to get 5 minus 0.08x. We can calculate what our average profit function will be. Well, that will just equal to our original profit function, all divided by x. And then lastly, if we wanted to calculate the marginal average profit function, well, that's just taking the first derivative of this guy. So let's rewrite this guy in a way that we can easily apply our derivative rule. And we're going to get minus 100x to the minus 1 plus 5 minus 0.04x. And now, well, that's not, let's move this a little bit. This, what we have just solved, is equal to our average profit function. And all I did was divide each term by the denominator, so that way we can more easily apply our derivative rule to that. So if that is the average profit function, we can now take the derivative of this to find out the marginal average profit function. And we're just going to get positive 100 x to the minus 2 plus 0 minus 0.04. So that will equal to 100 x to the minus 2 minus 0.04. Alright, well that does it for today. Y'all take care.